Okay. So once again, very good morning all. So in the last lecture, we have started the numericals based on the bending stress calculation for the I section and the T section. And in the previous lecture, I think we have solved the three problems based on the calculation of the bending stresses for the unsymmetrical I section and for the unsymmetrical T section. So the two problems we have solved for the T section, where we have calculated the their bending stresses in the form of tensile and the compressive stresses, and one more additional value we have calculated, that is tensile force. And how to calculate the tensile force, that also we have discussed in the previous lecture. And before that, one problem we have solved for the unsymmetrical I section, where we have calculated the bending stresses, and in that we have discussed how the statement will be given, how the type of beam is mentioned in the statement, or if the type of beam is not mentioned in the statement, then that sagging and the hugging bending moment it is mentioned in the statement. Or if the type of beam is not there, then sagging and hugging bending moment, this concept is not represented in the statement, then we can unable to verify that whether that beam is subjected to the simply supported beam or that beam is subjected to the cantilever beam. So we are unable to calculate the sigma T and sigma C. We will calculate bending stresses above the neutral axis and below the neutral axis, but we are unable to define where sigma T is present and where sigma C is present. So if we have to segregate where sigma T is present and where sigma C is present, it must be there, that is type of beam it should be mentioned in the statement, or the sagging and hugging bending moment it should be mentioned in the statement. But no problem, we have solved problems based on that also. If the type of beam is not mentioned or if the type of beam is mentioned, how to solve the numericals. So now in the today's lecture, we will solve again the two numericals based on the I section. One is for the unsymmetrical and another is for the symmetrical I section. And instead of calculating the bending stresses, now we are going to calculate the load value. So now if you remind all the previous numericals, in that the value of W is given. So maybe the cantilever beam is subjected to the point load at free end, cantilever beam is subjected to the UDL on entire span, then simply supported beam is subjected to the point load, simply supported beam subjected to the UDL. So these are the four standard cases in that the value of W is given. But now what are the problems we are going to solve in the today's lecture? So here the value of W we have to calculate. The value of W we have to calculate, and how to solve that particular problem, that we will discuss in the today's lecture. Okay. So now this is the statement in front of you. So you just read that particular statement and then we will go for the solution. So what this particular statement? The cast iron beam of I section, the cast iron beam of I section is simply supported on a span of 6 meters. So the section of the beam is given as a I section, okay, and the type of beam is also mentioned, that is simply supported beam, and the total length of the beam is given 6 meters. Okay, this section consists of top flange, that is top flange dimensions are given 60 mm by 20 mm. Just I will check whether it is 60 or 600. Yes, correct. It is 60 mm by 20 mm, the dimensions of the top flange. Then web dimensions are 180 mm by 20 mm, and the bottom flange is 160 by 40 mm. So if you check the dimensions of the top flange and the bottom flange, so the top flange dimensions are 60 mm by 20 mm and bottom flange dimensions are 160 by 40. Whether this I section is symmetrical or unsymmetrical?
Unsymmetrical.
It is unsymmetrical because the dimensions of the top flange and the bottom flange are totally different. Getting? If the dimensions of the top flange and bottom flange, if it is same, then easily we can say that the given section will be the symmetrical section. But here the dimensions are different. Therefore, whatever the I section is mentioned, it is having some two unequal flanges. Therefore, it is unsymmetrical. First up, find the UDL on the beam. Up till now आपल्याला UDL ची व्हॅल्यू दिलेली असते 20 kilonewton meter, 10 kilonewton meter, but here they have asked find UDL on the beam if tensile stress should not exceed 30 Newton per mm square. Also find corresponding maximum compressive stress. So this is the statement in front of you. So what is the difference between this statement and the previous statement? So in the previous, all the numericals, the value of load is given. Maybe it is subjected to the UDL, for example, 20 kilonewton meter. If the beam is subjected to the point load, that point load value is equal to 30 kilonewton, like that. And we have to calculate the bending stresses. Maybe we have to calculate the sigma T and we have to calculate the sigma C also. But here we have to find out value of UDL. That means W value we have to calculate. And for that calculation, they have mentioned the tensile stress should not exceed 30 न्यूटन पर mm स्क्वेअर. म्हणजे दोन बेंडिंग स्ट्रेस पैकी एक बेंडिंग स्ट्रेस ऑलरेडी आपल्याला स्टेटमेंट मध्ये दिलेला तो म्हणजे किती सिग्मा टी इज इक्वल टू 30 न्यूटन पर mm स्क्वेअर. मग याचा वापर करून आपल्याला W ची व्हॅल्यू फाइंड आउट करायची आहे. and after this calculation we have to calculate the corresponding compressive stress also. म्हणजे सिग्मा टी तर दिलेला आहे पण त्याचाच वापर करून आपल्याला सिग्मा सी means another bending stress also we have to calculate. So this is the statement. So first of all, we have to write down all the given parameters and then we have to draw the figure for the unsymmetrical I section. So what is the important given parameters? So dimensions need not required to write, but what is another dimensions are, that is length of beam is equal to 6 meter is equal to 6000 mm and the type of beam is mentioned simply supported beam. Simply supported beam. Then the beam is subjected to the some amount of tensile stress, that is sigma T. It is equal to 30 Newton per mm square. And we have to calculate the value of W, that is value of UDL, and we have to calculate the another compressive stress, that is sigma C. So these are the most important parameters which are required for the calculation. The tensile stress should not exceed 30 Newton per mm square, means this is the maximum value. Your beam can sustain the stress up to 30 Newton per mm square only. If your stress is exceeds more than 30, there is a possibility of failure of the beam. So they have mentioned the word should not exceed, means it represents the maximum limit of the beam. Okay, so these are the given parameters. Now, as per the dimensions of the I section, first of all, we have to draw the unsymmetrical I section. So the top flange, the dimensions of the top flange is less than the dimensions of bottom flange. So dimensions of the bottom flange is maximum as compared to the top flange. So accordingly, you have to draw the figure. So this is the unsymmetrical I section. So for the top flange, 60 mm is the length, and what is the width? 20 mm. So this is the 20 mm depth. Then the wave dimensions are given 180 by 20 mm. So here the 180 we have to consider as the total height, and this 20 mm we have to consider the depth. So this is equal to 20 mm and the height is 180 mm. And then the bottom flange, the length is 160. So this is the bottom 160 and their height is given 40 mm. Okay, so this is the unsymmetrical I section. This is the unsymmetrical I section. So in front of that, we just leave some space to represent the value of y bar, to represent the value of neutral axis. So this is the section number 1, that is horizontal rectangle number 1. Section number 2 will be considered as a vertical rectangle, and section number 3 will be considered as a horizontal rectangle. So this is the top flange. This is the top flange. This is the web, and this is bottom flange. Okay. Also, we have to represent all the distances on the figure, that is y1, y2, y3, because this is the section which is unsymmetrical. So here we need to calculate your y bar by using the formula a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3. So it will be better to represent all the distances. This is the CG of section 1. Then web, this is the CG of section 2. And the third section, their CG, that is at the center, that is CG of section 3. So this is your y1, this is y2, and this is y3. Okay, so these are all the important CG points of section number 1, section number 2, and section number 3. So first of all, we have to calculate all the cross-sectional areas of all the 3 sections, then their CG distances in the form of y1, y2, y3, and we have to calculate the y bar. So go for the further calculation. We have followed the same procedure for all the 3 problems which we have solved in the previous lecture, maybe T section or maybe unsymmetrical I section. So you need to calculate all the cross-sectional areas. Tell me the values. So here I will write A1, then Y1, then A2, Y2, A3, and Y3. So what is the A1? What is the area A1? 160 into 40, which is equal to how much? 64,000. 6,400 or 64,000? Then what is the y1 distance? 40 divided by 2 is equal to 20 mm. Then A2, this is the area for the vertical rectangular section. Their dimensions are 180 by 20. So what is this area? How much? 3,600. And then y2 distance is equal to this 40. We have to take as it is. 40 plus 180 divided by 2. How much? 130 mm. And area A3 is equal to 60 into 20. 1,200 mm square. And y3 is equal to this 40 mm as it is, plus 180 mm as it is, plus 20 divided by 2. How much? 230 mm. So these are the all important distances, that is A1, A2, A3 calculation as per the dimensions of all the 3 sections, and then y1, y2, y3. So you have to represent all the y1, y2, y3 distances on the figure. How it is 40 plus 180 divided by 2? Sometimes we are making 180 plus 40 and divided by 2. It is not like that, because the second vertical rectangle is having their original vertical dimension is 180. So we have to take the CG of section 2 only. That particular sections आपण CG काढतो, त्यामुळे त्याचंच vertical distance divided by 2 करतोय आणि राहिलेले distance आपण as it is त्याच्यामध्ये add करतो. Okay, so these are all important dimensions. Now tell me the value of y bar. So y bar is equal to a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3. Put all the values and tell me the y bar. What will be the y bar value? And it will be from bottom side. Means we have to represent the position of neutral axis.
77.85.
How much? 77.85 mm, which is equal to. So now the type of beam is mentioned. Barabar. Which type of beam is given? Simply supported beam is given. So if I will draw the position of neutral axis, now see, you have to draw one center line like this, and this is your neutral axis, and आल्याला y bar ह्या ठिकाणी represent करा. So this will be the first y bar which we have calculated, that is y bar is equal to y bar is equal to 77.85 mm. So now below the neutral axis, whether your simply supported beam is under tension or compression, below neutral axis, it is tension or compression? Tension. So whatever the y bar we have calculated, whether it is yt or yc, yt. So first y bar is equal to yt. You have to represent on the figure also, that is yt. And then another y bar, that is which is present above the neutral axis, that also we have to represent on the figure. So this is y bar is equal to yc is equal to. So how it is to be calculated? What is the total height? 180 plus, that is 240 is the total height, correct? Therefore y bar is equal to yc is equal to 240 minus 77.85, which is equal to, what is the total yc distance? 162.15 mm. So represent this distance also on the figure, that is position of neutral axis from the top side, it is 165.15 mm. (162). So these are all the important distances, that is in the form of y bar. So the first y bar from the bottom side and the another y bar is from the top side. So initially whatever the y bar we have calculated, we have to represent from the bottom side only, because y1, y2, y3 distances we have taken from the bottom side. So now we have represented the position of neutral axis. Upon neutral axis position find out केली आता दोन्ही y bar कडून. Now we have to go for the moment of inertia calculation. So we have to calculate it by using the formula Ixx is equal to Ixx1 plus Ixx2 plus Ixx3. So first Ixx1 is equal to BD cube or B1 D1 cube divided by 12 plus A1 in bracket y bar minus y1 bracket square. So 160 into 40 cube divided by 12 plus 6400 in bracket 77.85 minus first y1 is equal to 40 bracket square. Now do the calculations properly. Ixx2 is equal to B2 D2 cube divided by 12 plus A2 in bracket y bar minus y2 bracket square. So 20 into 180 cube divided by 12 plus 3600 in bracket 77.85 minus y2 is equal to 130 bracket square, and third one is equal to Ixx3 is equal to B3 D3 cube divided by 12 plus a3 in bracket y bar minus y3 bracket square, which is equal to 60 into 20 cube divided by 12 plus 1200 in bracket 77.85 minus y3 is equal to 230 bracket square, and tell me the total ixx by adding all the values. Do one by one calculation. ixx1, ixx2 and ixx3. ixx is equal to 20. ixx1 is equal to 22 point into 10 raised to 6 mm raised to 4. Please check and verify your answer. 19.51 into 10 raised to 6 mm raised to 4. Do the calculations and send your answers in the chat box. ixx1, ixx2 and ixx3. So 22.27, or maybe sometimes you will get some another values after the point. ixx3 is equal to 27.81 into 10 raised to 6 mm raised to 4. We check and verify your answers. ixx1 value, ixx2 value and ixx3 value. Do the calculations and send me the all answers in the chat box. ixx1, ixx2 and ixx3. Don't write the value as it is, you have to do the calculations, because this calculation is very, very important. Yes, 22.27 into 10 raised to 6, correct. Just you have to verify your answers by doing the calculations. Then simply you have to make the addition of all the three values and you have to calculate the total ixx is equal to 69.59 into 10 raised to 6 mm raised to 4. Send all the answers in the chat box. Those who have calculated, yes, 22.27, 19.51 and 27.81 into 10 raised to 6. Everyone has to do the calculation and send the answer in the chat box. Do the calculations immediately and send the answers in the chat box. Those who are attending online, today's attendance will be marked based on your responses. जरी तुम्ही रोल नंबर टाकला तर मी आजची attendance consider करणार नाही. If your response is there in the chat box, then your attendance will be marked. Otherwise, there will be the absent. So you have to do the calculations and send the answers in the chat box. So you have to calculate three values: ixx1, ixx2, ixx3, and simply at the end you have to do the additions to calculate the total moment of inertia. Okay, so now the moment of inertia is calculated. Now we have to go for the further things. So now what they have asked, we have to calculate the UDL. That means we have to calculate the quantity or magnitude of the load which is spread on that particular simply supported beam. Okay, and for that calculation they have mentioned one bending stress that is in the tensile condition. So first of all, what we will do, we are having one formula. What is that formula? That is as per simply supported beam condition. The beam is subjected to the UDL on entire span. Beam is subjected to the UDL on entire span, and the type of beam is also mentioned. So what is the value of M? Capital M is equal to, what is the M formula? The beam subjected to the UDL on entire beam, and the type of beam is also mentioned, that is simply supported beam. W L square upon 8. What is the value of W? We have to calculate, so keep as it is. What is the value of length? 6000 square divided by 8. Tell me this value. Capital M in the form of W. That is 6000 square divided by 8. Ite value sanga. In the form of W, you have to write down the M value. How much? 4.5 into 10 raised to 6. So keep this value as it is. That is value of bending moment in the form of W. Okay, now use our regular formula. What is the formula? M upon I is equal to sigma upon Y. Okay, so this is the first formula. What I will do, I will write this formula in the form of tensile stress and the compressive stress. So what you have to write? M upon I, this is the common, which is equal to sigma T upon YT. And another formula, M upon I is equal to sigma C upon YC. So this is the equation number 1, and this is the equation number 2. This is the equation number 1 and the equation number 2. What I have done, M upon I, this is common for the tensile stress calculation and the compressive stress calculation. So what I will do, I will take the first combination for my further calculation. If I have to calculate the value of W, so as per equation 1, so M upon I is equal to sigma T upon YT. So what is the value of M? What is the value of M? 4.5 into 10 raised to 6 into W. What is the value of I? 69.59 into 10 raised to 6. What is the value of sigma T? Sigma T, 30 Newton per mm square. And what is the value of YT? 77.85. Then tell me the value of W. So W is equal to 30 into 69.59 into 10 raised to 6 divided by 77.85 into 4.5 into 10 raised to 6. What is the value of W? 5.95 Newton per mm. Getting? 5.95 This is the value of W, Newton per mm, because your UDL will be given in the form of Newton per meter or kilonewton per meter. बघा आपल्याला आतापर्यंत जेवढे आपण प्रॉब्लेम सॉल्व्ह केले त्याच्यामध्ये तुम्हाला 20 kilonewton per meter अशी जर व्हॅल्यू दिली असेल तर आपण काय करतो, this 20 we have 20 kilonewton per meter we are converting in Newton per mm. मग काय करतो 20 into 10 raised to 3 divided by 10 raised to 3, 10 raised to 3, 10 raised to 3 will get cancelled, only 20 Newton per mm. So here directly you will get this particular value, that is 5.95 Newton per mm. So this is the value of W, that is value of UDL which is spread on the entire beam. So this is the value of W which is spread on the entire beam. So please keep in mind, जर आपल्याला W ची व्हॅल्यू जर काढायला सांगितलेली असेल तर त्या ठिकाणी 101% वन बेंडिंग स्ट्रेस विल बी गिवन टू यू. आतापर्यंत आपण जेवढे काही प्रॉब्लेम सॉल्व्ह केले त्याच्यामध्ये आपल्याला in all the statement the value of W is given, and by using that value of W we have calculated sigma T and sigma C. जर तुम्हाला W ची व्हॅल्यू दिली नसेल आणि तुम्हाला कुठलाच बेंडिंग स्ट्रेस दिला नसेल तर we are unable to calculate the value of W. So please keep in mind, whenever they have asked to find out the value of load, it may be the point load, it may be the UDL, one bending stress will be given. It may be sigma T or it may be sigma C. एक बेंडिंग स्ट्रेस तुम्हाला दिलेला असेल मग त्याच्यामध्ये सिग्मा टी तर दिलेला असेल किंवा सिग्मा सी तर दिलेला असेल. आता मी हा पहिलाच फॉर्म्युला का वापरला, why I use this particular first formula, why I have used this particular first formula only, m upon I is equal to sigma T upon yt. Why I have not used m upon I is equal to sigma C upon yc? Here in the equation number 1 sigma T is given, therefore there is only one unknown, that is W. जर मी सेकंड इक्वेशन जर वापरला असता तर हा m च्या फॉर्म्युला मध्ये 4.5 into 10 raised to 6 into W हे पण अननोन राहिला असतं, आणि सिग्मा C it is also not given, therefore I have not used the second equation for the further calculation. Okay, now the W is calculated. Now we have to calculate the another bending stress, that is sigma C. So how it is to be calculated? So now you have to compare the equation number 1 and equation number 2. So what is the equation number 1? M upon I is equal to sigma T upon yt, and equation number 2 M upon I is equal to sigma C upon yc. जर त्याच्या लेफ्ट हँड साइड जर इक्वल असतील तर right hand sides are also becomes equal. Therefore from equation 1 and 2, that is LHS is equal to RHS. मग लेफ्ट हँड साइड कुठला इक्वल आहेत, m upon I, m upon I. जर ह्या दोन व्हॅल्यू जर इक्वल असतील तर राहिलेले दोन इक्वेशन पण इक्वल होणार, दॅट इज सिग्मा T upon yt is equal to sigma C upon yc. Therefore 30 divided by 77.85, sigma C is the unknown. What is the value of yc? 162.15. Therefore sigma C is equal to 30 into 162.15 divided by 77.85. Therefore sigma C is equal to, what is the value of sigma C? What is the value of sigma C? 62.48 Newton per mm. Same, you can use this combination also. M upon I is equal to sigma C upon yc. हे जर इक्वेशन घेऊन तुम्ही काढलं तरी पण तुमची व्हॅल्यू सेमच येणार, कारण हा m च्या ह्याच्यामध्ये तुम्हाला माहित आहे m is equal to 4.5 into 10 raised to 6 into W. आता W ची व्हॅल्यू आपल्याला माहित आहे किती, 5.95. त्याच्यावरून तुम्हाला बेंडिंग मोमेंट मिळेल. I ची व्हॅल्यू ऑलरेडी दिलेली आहे, yc is already calculated, there is only one unknown, that is sigma C. So you can use any combination. तुम्ही लेफ्ट हँड साइड and राइट हँड साइड इक्वल करून हे इक्वेशन नंबर 3 जनरेट करून जरी काढलं then answer will be same. and by using the formula m upon I is equal to sigma c upon I by c, then also your answer will be same. And in the statement they have asked also find corresponding maximum compressive stress. They have used the maximum word. So तुम्ही sigma t आणि sigma c जर compare केले, so which will be the maximum value? If we are comparing the value of sigma t and sigma c, which will be the maximum value? Sigma c is the maximum. Therefore, they have mentioned in the statement, find the corresponding maximum compressive stress. कारण sigma t आपला 30 न्यूटन per mm square आहे आणि आलेली sigma c ची व्हॅल्यू किती आहे? 62.48 Newton per mm square. So you can use any combination by using equation number 2. Then also we can calculate value of sigma c, and by comparing equation 1 and 2, you will get the equation number 3. LHS is equal to RHS. By using the equation number 3 also, you will get the same value, that is 62.48 Newton per mm square. So this is the one variety of the problem which is also asking in the examination. Instead of calculating the bending stresses, sometimes the bending stress is given and from that we have to calculate the value of W. आतापर्यंतचे जे काही सगळे प्रॉब्लेम आपण सॉल्व केले मागचे, in all the three problems the value of W is given and we have calculated only bending stresses in the form of sigma T and sigma C. याच्या अगोदरच्या सगळ्या प्रॉब्लेम मध्ये आपण फक्त आणि फक्त bending stresses find out केलेला आहे. But now in this today's problem, bending stress is given and we have calculated the value of W. आणि W ची व्हॅल्यू कॅल्क्युलेट करताना त्या स्टेटमेंट मध्ये एक तर तुम्हाला सिग्मा टी ची व्हॅल्यू दिली असेल किंवा सिग्मा सी ची व्हॅल्यू दिलेली असेल. दोन्हीपैकी एक बेंडिंग स्ट्रेस दिलेला असतो, त्याचा वापर करून आपल्याला W ची व्हॅल्यू काय करायची आहे, फाइंड आउट करायची. प्रोसिजर तीच आहे, फक्त अननोन पॅरामीटर वेगळे. बघा आपण सिग्मा टी पण काढण्यासाठी आपण हीच प्रोसिजर फाइंड आउट केली, y बार ix after that m upon I is equal to sigma upon y, and for the calculation of W also we have followed the same procedure, only unknown parameters are different. So please check the value of W is equal to 5.95 and your another maximum compressive bending stress, it is equal to 62.48 and it can be calculated by using the equation number 2 or by using the equation number 3. Any equation we can use, answer will be same. Okay, finish. Have you got the answers? Okay, now take next problem and the last from this chapter. It is very simple for the calculation. I will give you the statement, you just write down the statement. A symmetrical I section, write down the statement in the notebook, it is not on the PPT. Write down the statement. The symmetrical I section is 150 mm wide. Symmetrical I section is 150 mm wide and 200 mm deep. 150 mm wide and 200 mm deep. Full stop. The flange and web thickness is 10 mm. The flange and web thickness is 10 mm. Full stop. This section is used for cantilever beam. This section is used for cantilever beam having length 10 3 meter, having length 3 meter, subjected to UDL, having length 3 meter, subjected to UDL, full stop. Find maximum UDL value. Find maximum UDL value. Find maximum UDL value that can be supported. That can be supported if capital E is equal to 200 gigapascal. If capital E is equal to, that is Young's modulus, is equal to 200 gigapascal, and maximum allowable stress is, and maximum allowable stress is 180 megapascal. 180 megapascal. Full stop. The symmetrical I section. Symmetrical I section. So you have to draw the figure for the symmetrical I section where the top flange dimensions and the bottom flange dimensions will be same. What they have given, see, 150 mm wide and 200 mm deep. Total I section ची width किती सांगितले? 150 mm आणि टोटल आय सेक्शन ची हाईट किती सांगितले? 200. बघा ह्याच्यामध्ये वेबचं डायमेन्शन कुठे दिसतंय का तुम्हाला? वेबचं डायमेन्शन आपल्याला त्या फिगर मध्ये डिफाइन करायचं. सो फर्स्ट ऑफ ऑल ड्रॉ द फिगर फॉर द सिमेट्रिकल आय सेक्शन. सिमेट्रिकल आय सेक्शन म्हणजे दोन्ही फ्लॅंज तुम्हाला सेमच काढायचे. सो द टॉप फ्लॅंज अँड द बॉटम फ्लॅंज. So this is the I section. What is the total dimension? 150 mm wide. 150 mm wide and 200 mm deep. म्हणजे total height. Total height किती दिले बघा? 200 mm. And flange thickness and wave thickness. म्हणजे फ्लॅंज कुठल्या झाल्या? दोन्ही पण झाल्या, बरोबर? This is 10 mm top flange thickness. This is 10 mm bottom flange thickness, and wave thickness is also 10 mm. Then what is the height of wave? 180 mm. This is very important. So this is section 1, this is section 2, and this is section 3. And what is the dimensions of the flange, bottom flange? त्याची width किती असणार आहे सांगा? 150. Because this is the symmetrical I section. त्यामुळे देताना त्यांनी काय दिले बघा? I section ची width आणि I section ची depth. ह्याच्यामध्ये टॉप फ्लॅंज चे वेगळे डायमेन्शन, बॉटम फ्लॅंज चे वेगळे डायमेन्शन किंवा वेब चे वेगळे डायमेन्शन दिलेले नाहीत. We have to define it on the figure. So this is the figure that is for the symmetrical I section. Now the section is symmetrical about the x axis. Why the section is symmetrical about the x axis? Why the section is symmetrical about the x axis? The dimensions of the top flange and bottom flange. इट इज सेम, बरोबर आहे. त्यामुळे ह्या टोटल आय सेक्शनचा सीजी पॉइंट बरोबर कुठं कॉन्सन्ट्रेट होणार आहे, बरोबर सेंट्रलला, बरोबर. म्हणजे थ्रू दिस आय सेक्शन डायरेक्टली आय कॅन रिप्रेझेंट द पोझिशन ऑफ न्यूट्रल ऍक्सिस लाईक दिस. याच्या अगोदर आपण डायरेक्ट रिप्रेझेंट करू शकत होतो का टी सेक्शन आणि आय सेक्शन साठी, कारण आपल्याला माहित नव्हतं की ते बरोबर सेंटरला आहे का नाही. सो इट रिप्रेझेंट्स द पोझिशन ऑफ न्यूट्रल ऍक्सिस एक्झॅक्टली ऍट द सेंटर पॉइंट. So now how to calculate the y bar? How to calculate the y bar? For the symmetrical I section, direct formula is available. Total height divided by 2. कारण total I section ची height किती आहे, 200 mm. जर आपण directly y bar is equal to 200 divided by 2, it is equal to 100 mm. Directly we can calculate the y bar like this because this section is symmetrical about x axis. So here I will represent both the y bars on the figure. So this first y bar is equal to 100 mm and another y bar is equal to also 100 mm. So directly we can calculate y bar is equal to 200 divided by 2. In front of that, write down section symmetrical about x axis. Section symmetrical about x axis. Y bar is equal to 200 divided by 2. Then we are having another formula for the moment of inertia calculation. Ix is equal to capital I is equal to capital BD cube divided by 12 minus capital B minus small b into small d cube divided by 12. So Ix is equal to capital I is equal to, आता capital B आणि capital D कुठला असणार आहे capital B? What is the capital B? Capital B 150 and what is the capital D? 200. So write down capital B is equal to 150 into 200 cube divided by 12. आता काय करतोय बघा आपण ह्याच्यामध्ये हा डायरेक्ट फॉर्म्युला वापरतो. म्हणजे मी तुम्हाला सांगितलं होतं ह्या टोटल रेक्टँगल हा जर मी जॉईन केला, हा सेक्शन वर्टिकल बघा, हा वर्टिकल सेक्शन जर जॉईन केला तर हा आपल्याला एक मिळताना काय मिळतोय, एक रेक्टँगल मिळतोय. ह्या मोठ्या रेक्टँगल मधून जर हे कडचे स्मॉल रेक्टँगल जर मी सबट्रॅक्ट केले तर आपल्याला कुठला सेक्शन मिळतोय, आय सेक्शन मिळतोय. मग तो सेक्शनचा आपल्याला मोमेंट ऑफ इनर्शिया काढण्यासाठी आपण हा फॉर्म्युला डेराइव्ह केलाय. मग पहिल्यांदा काय केलं त्यांनी, ह्या मोठ्या रेक्टँगलचा मोमेंट ऑफ इनर्शिया, रेक्टँगलचा मोमेंट ऑफ इनर्शिया काय असतो, BD क्यूब डिवाइड बाय 12, बरोबर. मग कॅपिटल बी किती दिलाय, 150, कॅपिटल डी किती दिलाय 200. मग पहिल्यांदा 150 into 200 डिवाइड बाय 12 मायनस, आता बघा आता हे कडचे जे काही दोन रेक्टँगल आपल्याला सबट्रॅक्ट करायचे, त्याची आपल्याला बी ची व्हॅल्यू काढायची. बी व्हॅल्यू म्हणजे कुठली येणार आहे बघा, इकडची एवढी साइड आणि दिस साइड, मधली साइड येणार आहे का त्याच्यामध्ये, हे वेबचं डायमेन्शन आपल्याला येईल का त्याच्यामध्ये, कारण हा आय सेक्शनचा पार्ट आहे. वेब म्हणजे हा व्हर्टिकल वेबचा हा पार्ट आहे. मग हे दोन सेक्शनचं जर डायमेन्शन आपल्याला काढायचं असेल तर ह्या टोटल 150 मधून आपल्याला कुठलं डिस्टन्स सबट्रॅक्ट करावं लागेल, हे वेबचं डायमेन्शन 10 mm सबट्रॅक्ट करावं. म्हणजे 150 मायनस 10 हे जर केलं तर तुम्हाला हे डायमेन्शन मिळाले. दॅट्स वाय आय हॅव रिटन कॅपिटल बी मायनस स्मॉल बी. मग कॅपिटल बी किती आहे 150 मायनस 10 आणि जे दोन रेक्टँगल आपल्याला सबट्रॅक्ट करायचे त्याची हाईट किती आहे 180. सो हियर डायरेक्टली आय कॅन राईट 180 क्यूब डिवाइडेड बाय 12. Then tell me the value of I. Either you can use this formula or either you can use another formula. Find the separate Ixx1, Ixx2, Ixx3 separately. कुठलं सोपं आहे? This is very simple because it will reduce your calculation part. And previous also y bar पण तुम्ही y bar is equal to a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3. हा फॉर्म्युला जरी तुम्ही वापरून काढला तर तुम्हाला y bar is equal to 100 mm एवढंच येणार आहे. What is the moment of inertia? You check 31.96 into 10 raised to 6 mm raised to 4. Please check your answer. Send me answers in the chat box. What is the moment of inertia? Whether it is coming 31.96 into 10 raised to 6. Direct formula we are having for the symmetrical I section. That formula I have given while giving the list of all the formulas. You check your answer 31.96 into 10 raised to 6 mm raised to 4. Okay. Now the type of beam is mentioned. Which type of beam is given? Which type of beam is given? As per cantilever beam condition. As per cantilever beam condition. So what is the M formula? Cantilever beam subjected to the UDL on entire span. Kya M formula? Case number 4. W. What is the M formula?
WL square by 2.
WL square divided by 2. So W we have to calculate. What is the length? 3000 square divided by 2. Tell me the value of M in the form of W. That is W into 3000 square divided by 2. किती येते? 4.5 into 10 raised to 6. So this is the moment in the form of value of W. The moment in the form of W as per the cantilever beam condition. Cantilever beam subjected to the UDL on entire span. त्या condition साठी आपल्याला formula आहे WL square divided by 2. W keep as it is. Put all the values and find the M in the form of W. Now the maximum allowable stress, it is equal to 180 megapascal, which is equal to 180 Newton per mm square. माहिती आहे का आपल्याला हा टेन्साइल का कॉम्प्रेसिव्ह आहे? माहिती आहे का? What they have given one statement, maximum allowable stress. बरोबर, आपल्याला माहिती आहे हा बेंडिंगच आहे. 180 Newton per mm square. This is the bending stress, but we don't know. Like previous problem, in the previous problem they have mentioned the tensile stress is equal to 30 Newton per mm square and find out the maximum compressive stress also. But here they have mentioned only one statement, that is maximum allowable stress is equal to 180 megapascal, which is equal to 180 Newton per mm square. So we don't know whether this 180 mm is equal to sigma T or whether this 180 mm is equal to sigma C. So don't verify it. So directly we can write down the formula, that is M upon I is equal to sigma upon Y. मग Y कुठला घेणार? सिग्मा T जरी घेतला किंवा सिग्मा C जरी घेतला तर दोन्हीची व्हॅल्यू काय आहे? सेम आहे. So that's why directly we can write down the formula M upon I is equal to capital Y. जर ह्या ठिकाणी Y बार जर वेगवेगळे असले असते तर हा 180 तुम्हाला आयदर सिग्मा T तर दिलेला असता किंवा सिग्मा C तर दिला. जर हा सिग्मा T दिला असता तर तुम्ही Y काय घेतला असता? बेंडिंगच्या फॉर्म्युलामध्ये जर हा 180 mm जर सिग्मा T दिला असता तर हा Y काय घेतला असता? YT घेतला असता. जर हा 180 mm सिग्मा C दिला असता तुम्ही हा काय घेतला असता? YC. But here both YT is equal to YC is equal to your capital Y. So directly I can use the direct formula. So now put the values. 4.5 into 10 raised to 6 into W What is the value of I? 31.96 into 10 raised to 6, which is equal to 180 divided by 100. त्याच्या पुढे लिहा sigma is equal to sigma t is equal to sigma is equal to sigma t is equal to sigma c, and capital Y is equal to y bar is equal to yt is equal to yc. This is because the section is symmetrical about x axis. Now tell me the value of W. So write down the equation in the form of W is equal to 180 into 31.96 into 10 raised to 6 divided by 100 into 4.5 into 10 raised to 6. W is equal to 12 point into 10 raised to 6 is a Newton per mm, or into 10 raised to 6 is not there, no? So 12.78 into 10, 12.78 Newton per mm, which is equal to 12.78 kilonewton per meter. युनिट सेम राहणार आहे, युनिट वेगळा असणार आहे, फक्त व्हॅल्यू काय असणार आहे, सेम असणार. कारण आपण बघितलं एवढेच जरी आपण पॉइंट नोड मध्ये कन्वर्ट केलं तर व्हॅल्यू तेवढीच राहते, फक्त युनिट काय होते, चेंज होते. बिकॉज 10 raised to 3 फ्रॉम द न्यूमरेटर अँड 10 raised to 3 फ्रॉम द डिनॉमिनेटर हे कॅन्सल होते. त्यामुळे मॅग्निट्यूड फक्त सेम राहते, तुमची युनिट फक्त काय होते, चेंज होते. सो दिस इज द व्हॅल्यू ऑफ W. What is the difference between this problem and the previous problem that we have to understood? In the previous problem, someone's mic is on. Sudhir Raut.
Yes, sir.
Your mic is on. Okay. So you need to understand the difference between this problem and in the previous problem. In the previous problem, the section is unsymmetrical. Therefore, specifically they have mentioned sigma t is equal to 130 Newton, 30 Newton per mm square. त्यामुळे आपण फॉर्म्युला देतानाच m upon I is equal to sigma t upon yt दिला होता. But here, whatever the 180 megapascal stress is given, they have not mentioned whether it is sigma t or whether it is sigma c. Therefore, instead of representing the bending stress formula in the form of sigma t yt, sigma c yc, directly we can use m upon I is equal to sigma upon y. त्याच्यामध्ये सिग्माची व्हॅल्यू तुम्हाला दिलेली आहे and y व्हॅल्यू इज ऑल्सो सेम. त्यामुळे तुम्ही न्यूट्रल ऍक्सिसचा वरचा y कन्सिडर केला किंवा न्यूट्रल ऍक्सिसचा खालचा y कन्सिडर केला, इट इज इक्वल टू 100 mm. So that's why we can use the direct formula and we can calculate the value of W. So this is about the problem for the symmetrical I section. And with this particular problem, we have finished this chapter number 6. Getting? Everyone have understood variety of the problems? Whatever the procedure we have followed for all the problems, it is same. Y bar calculation procedure is same. Moment of inertia calculation procedure is same. फक्त आताचे दोन जे काही प्रॉब्लेम आपण स्टडी केले त्याच्यामध्ये टेन्साइल स्ट्रेसेस काढण्याच्या ऐवजी आपण W च्या व्हॅल्यू फाइंड आउट केलेत आणि त्याच्या अगोदर जे काही प्रॉब्लेम सॉल्व्ह केले होते त्याच्यामध्ये W ची व्हॅल्यू दिली होती and by using that we have calculated the bending stresses. So only this much variety is there in this particular bending stress of the beams, that is chapter number 6. Have understood all the concepts? So in this particular chapter, the assumptions made in bending, this is very important. Then concept of pure bending, it is very important. Then where bending stress is 0 and where bending stress is maximum, that concept is also very, very important. Then procedure of Y bar calculation for the symmetrical unsymmetrical section, procedure of moment of inertia calculation for the symmetrical unsymmetrical section, and this derivation m upon I is equal to sigma upon y is equal to E upon R. बघा आपण E upon R हे कुठेच यूज केलेलं नाही. बेंडिंग स्ट्रेस फॉर्म्युला जो काय आपण डिराइव्ह केला m upon I is equal to sigma upon y is equal to E upon R. त्या तीन कॉम्बिनेशन पैकी आपण मॅक्सिमम m upon I is equal to sigma upon y, this combination we have used for bending stress calculation. Getting? Have understood this particular चॅप्टर नंबर 6. एनी प्रॉब्लेम? सगळ्यांना समजलंय का प्रोसिजर? गेटिंग? So those who are attending online have understood chapter number 6. Any problem we can ask. Okay, one problem is given for the homework. So many times many students have made mistakes. तोच प्रॉब्लेम आहे जो आपण इथं सॉल्व्ह केला होता. तोच टी सेक्शन फक्त उलटा दिला. तुम्ही त्याच्या सिग्माच्या व्हॅल्यू जर चेक केल्या, फक्त सिग्मा टी ची व्हॅल्यू सिग्मा सी आली आणि सिग्मा सी ची व्हॅल्यू सिग्मा टी आली. तोच प्रॉब्लेम दिला होता, फक्त उलटा दिला होता. फक्त चेंज काय झाला होता? एरिया अंडर टेन्शन. जो प्रॉब्लेम आपण क्लासमध्ये सॉल्व्ह केला होता बघा, एरिया अंडर टेन्शन. एरिया अंडर टेन्शन तुमचा काय होता? बिलो न्यूट्रल ऍक्सिस. बरोबर. जो आपण क्लासमध्ये सॉल्व्ह केला होता तो काय होता? एक व्हर्टिकल रेक्टँगल होता. बरोबर. हा व्हर्टिकल रेक्टँगल होता. मग ह्या व्हर्टिकल रेक्टँगलचा एरिया आपण कसा काढला होता? 50 mm by their y bar. What is the y bar? 125 mm. बरोबर. 50 mm by 125 mm. तोच टी सेक्शन मी काय केला होता? इन्व्हर्ट केला होता आणि तुम्हाला असं सेक्शन मिळालं असेल मे बी. बरोबर. तोच सेक्शन आहे. मग आता हा पण सिग्मा टीचा आहे. हा पण एरिया कशाच्या अंडर आहे? टेन्शनच्या अंडर आहे. आणि हा राहिलेला कुठला आहे? कॉम्प्रेसिव्ह आहे. मग एरिया अंडर टेन्शन जर तुम्ही बघितला, जो होमवर्कला प्रॉब्लेम दिला होता, तर एरिया अंडर टेन्शन तुम्हाला काय मिळाला? व्हर्टिकल रेक्टँगल आहे का? मग कुठला सेक्शन आहे? एरिया अंडर टेन्शन. हा वरचा बघा, हा न्यूट्रल ऍक्सिसचा वरचा पोर्शन म्हणजे तुमचा हा झाला. पण आपल्याला कॅल्क्युलेट करायला काय सांगितले त्यांनी? तुम्हाला एक्सरसाइजचा प्रॉब्लेम दिला होता, टेन्साइल फोर्स कॅल्क्युलेट करायला सांगितलं होतं. बरोबर आहे का? होमवर्कच्या प्रॉब्लेमला टेन्साइल फोर्स कॅल्क्युलेट करायला सांगितलं होतं. आणि टाइप ऑफ बीम कुठला सांगितला होता? कॅन्टिलिव्हर और सिम्पली सपोर्टेड? सिम्पली सपोर्टेड. मग सिम्पली सपोर्टेडला न्यूट्रल ऍक्सिसचा खालचा पोर्शन काय असतो? टेन्शन. आणि न्यूट्रल ऍक्सिसचा वरचा पोर्शन काय असतो? कॉम्प्रेशन. मग आपल्याला टेन्साइल सांगितलं म्हणजे आपण न्यूट्रल ऍक्सिसचा खालचा कन्सिडर केला पाहिजे का वरचा कन्सिडर केला पाहिजे? टेन्साइल फोर्स काढायचा असेल तर, कारण वरचा पोर्शन हा कॉम्प्रेसिव्ह आहे. आपल्याला कॉम्प्रेसिव्ह फोर्स काढायला सांगितलंय का? नाही. मग ह्या न्यूट्रल ऍक्सिसचा हा एवढा पोर्शन जो मी हॅचिंग लाईनने इंडिकेट केलाय, तो कुठला पोर्शन मिळतोय तुम्हाला? व्हर्टिकल रेक्टँगल मिळतोय का कुठला मिळतोय? न्यूट्रल ऍक्सिसचा हा खालचा पोर्शन हा काय आहे? कुठला सेक्शन आहे? टी सेक्शन आहे. बरोबर आहे का? मग टी सेक्शनचा जर एरिया काढायचा असेल तर असं घेऊ शकतो का मी? 120 by 70 mm. 120 by 70 mm असं काढू शकतो का? कारण हा इथं तुम्हाला 120 by 70 हा रेक्टँगलचा झाला. मग हा रेक्टँगल आहे का? टी सेक्शन हा रेक्टँगल आहे का? जर 120 by 70 जर करावा लागला असता तर मला हा जोडावा लागला असता. बरोबर का? मग ह्या टी सेक्शनचा जर मला एरिया काढायचा असेल तर कसा काढणार? काय करणार? हा टी सेक्शन मध्ये दोन सेक्शन मध्ये डिवाइड करणार. हा सेक्शन नंबर 1 आणि हा सेक्शन नंबर 2. मग ह्या दोन्ही रेक्टँगलची जर मी बेरीज केली तर तुम्हाला कशाचा क्रॉस सेक्शनल एरिया येतोय? टी सेक्शनचा. मग काय करावं लागेल बघा, 120 into 20. बरोबर. 120 into 20 प्लस व्हर्टिकल रेक्टँगलचे डायमेन्शन्स काय? व्हर्टिकल रेक्टँगलचे डायमेन्शन्स काय? तिथनं एवढाच. व्हॉट इज द डायमेन्शन्स ऑफ व्हर्टिकल रेक्टँगल? काय करावं लागेल बघा, ही टोटल हाईट किती आहे? 70. ह्या 70 मधून किती सबट्रॅक्ट करावं लागेल? हे 20. म्हणजे किती हाईट मिळाली? म्हणजे काय आलं? 70 minus 20 into हे किती आहे डिस्टन्स? किती आहे?
20.
सो लाईक दॅट वी हॅव टू कॅल्क्युलेट. काय काय केले? 120 by 70 कॅल्क्युलेट करू शकतो का तसं डायरेक्ट? 120 into 70 दिस इज द एरिया ऑफ टी सेक्शन. कॅल्क्युलेट करू शकतो का? नाही. जर व्हर्टिकल रेक्टँगल असला असता तर डायरेक्टली आता व्हर्टिकल रेक्टँगलचा जर आपल्याला एरिया काढायचा असेल जो न्यूट्रल ऍक्सिसच्या वरचा आहे, त्याला आपण काय केलं असतं 130 mm बाय 20 mm, कारण एकच रेक्टँगल आहे ना, हा एकच रेक्टँगल आहे. त्यामुळे डायरेक्टली हॉरिझॉन्टल डिस्टन्स इंटू vertical distance, that is 20 into 130. But for the calculation of area for the T section, आपल्याला काय करावं लागेल, हॉरिझॉन्टल रेक्टँगलचा वेगळा एरिया कॅल्क्युलेट करावा लागेल, व्हर्टिकल रेक्टँग्युलरचा वेगळा एरिया कॅल्क्युलेट करावा लागेल आणि त्याची काय करावं लागणार आहे, ऍडिशन करावं लागेल. So please keep in mind, while calculating the tensile forces or compressive forces, area under tension हा रेक्टँगल आहे का टी सेक्शन आहे. जर तो रेक्टँगल असेल तर डायरेक्टली हॉरिझॉन्टल डिस्टन्स इंटू व्हर्टिकल डिस्टन्स, आणि जर तो टी सेक्शन असेल तर त्या टी सेक्शन मध्ये हॉरिझॉन्टल रेक्टँगलचा वेगळा एरिया कॅल्क्युलेट करा, व्हर्टिकल रेक्टँगलचा वेगळा एरिया कॅल्क्युलेट करा आणि त्याची काय करा, ऍडिशन करा. ठीक आहे. जर मी असं विचारलं असतं फाइंड आउट द कॉम्प्रेसिव्ह फोर्स, मग एरिया अंडर कॉम्प्रेशन कुठला आहे, न्यूट्रल ऍक्सिसचा वरचा आहे का खालचा आहे, area under compression, whether we have to consider the top side or bottom side. Area under compression top side, बरोबर आहे. area under compression, this is the top side. टाइप ऑफ बीम कुठला आहे, सिम्पली सपोर्टेड आहे ना, सिम्पली सपोर्टेड आहे का कॅन्टिलीवर आहे तुम्हाला दिलेला, एक्सरसाइजचा प्रॉब्लेम, एक्सरसाइजला दिलेला सिम्पली सपोर्टेड आहे ना, बरोबर आहे. मग हा एरिया अंडर कॉम्प्रेशन झाला. मग एरिया अंडर कॉम्प्रेशन कुठला क्रॉस सेक्शनल एरिया सांगा, व्हर्टिकल रेक्टँगल आहे का टी सेक्शन आहे, व्हर्टिकल रेक्टँगल. त्यामुळे डायरेक्टली 130 बाय 20 मी काढू शकतो. त्यामुळे मी काय केलं होतं बघा, एक्सरसाइजचा प्रॉब्लेम तोच दिला होता, फक्त इन्व्हर्टेड दिला होता. बरोबर, समजला का डिफरन्स. जो आपण क्लासमध्ये सॉल्व्ह केला तो हा, तोच टी सेक्शन आहे. त्यामुळे एरिया अंडर तुम्हाला टेन्शन येताना हा व्हर्टिकल रेक्टँगल आला, बरोबर. एरिया अंडर टेन्शन हा व्हर्टिकल रेक्टँगल आहे. मग तूच टी सेक्शन मी काय केला इथं फक्त उलटा केला होता. त्यामुळे तुमचा एरिया अंडर टेन्शन येताना हा व्हर्टिकल रेक्टँगल येण्याच्या ऐवजी कुठला आला, परत एकदा अजून स्मॉल टी सेक्शन. So this difference we have to understand, because for the tensile force compression calculation and the compressive force calculation, area under tension and area under compression, that understanding is very very important. Getting? And with this we have finished this particular chapter, that is chapter number 6.